that having a commercial grade, and can be implemented in mostly firstly in TMB, and maybe in the next time maybe can commercialize to other utility. So what is the situation? So basically, current voltage control in TMB is decentralized. Means that we have many equipment, many controller at site, like a generation, substation, and control center. So they are not coordinated, not centralized. So generator have their own controller for voltage control. Substation, they have their own controller for such as for online changer, and all of that equipment is not coordinated. Means and the reactive power is not manageable.
The what power is not manageable? Reactive power.
Okay. So we can call it short form megawatt. Normally you only know the megawatt, so I'm talking about megawatt today. So basically voltage is related to megawatt. You can control the voltage by controlling the megawatt. So megawatt sources can be found from the generator, from the like a capacitor bank, reactor, what else? And you can control maybe from the tap changer, transformer tap changer. Okay. This is the situation. So this is a conventional way where we can generate power and transmit through a transmission line and distribute to a distribution substation, distribution area. And we have the control center here. We control and manage all the generation and transmit the power throughout the transmission system and distribute to a distribution system. Anyway, everything is here. Like for example, the generation, they have their own control. Like,
tunjuk je dah lah pening aku tengok. Dah cukup. Cukup. Okay.
So as I said previously, that at generation side they have their own controller. For example, the AVR, automatic voltage regulator for generator.
Louder.
Okay.
Louder. People at the back can't hear you.
And the transmission system and distribution system, they have their own control devices, the static power controller, tap changer, and so on. So all not in coordinated. What's the?
Apa tu? Tengok balik. Tak apalah.
Okay. Oh, I just copy-paste.
Copy-paste mana pula tu? Tak apa, buatlah.
Okay. Right. This is the first. The violation of the voltage.
Violation?
Yes, violation.
Dia kata violation?
Yes.
Ke variation?
Violation.
Violate?
Yeah. Voltage have their limit. They have their limit, the constraint. You have the
over the operating limit is violation.
Yeah.
Oh, okay.
System in power system.
Oh, okay. Understand. Violate.
So here you can see that this is
apa kau buat tu? Tunjuk je lah.
Okay. Voltage. This is
Voltage. Ya, okay.
over 24 hours period. Voltage not consistent. Large gap between the substation, between two areas. So
you need to properly explain. The blue line represents.
Okay. This is
the blue line.
Yeah, the blue line
represents the voltage reading.
At all along the substation. This is one of the substation in the transmission substation.
The red line represents.
The red line also the voltage representing the voltage of the same substation, but with different time at a different time.
Different time.
We are comparing voltage different day at a different day in the same time period.
Are you trying to show the range?
No.
Apa ni?
This is the range. Okay.
0 hours to 3 PM.
Okay, 0 hours to 3 PM. This is because this picture I don't put it details. I mean the blue one is
Actual.
and this is the
Off.
yeah, but
Of what?
different.
OPF
Yeah, yeah.
OPF
Huh?
OPF VOPF
VOPF the optimal voltage. Yeah, the optimal voltage.
Oh, then bukan a different day.
Yeah.
So the red line is the optimal voltage.
The red one is the optimal voltage, and this is not the suboptimal voltage.
This is the actual voltage recorded.
Actual voltage
At the same
recorded.
time, right?
Yeah. This is okay.
Therefore-
I explain. Okay.
Okay. Okay, explain.
This is recorded.
Ah.
So we can get a snapshot
Okay.
from the transmission from the power system.
Okay.
So if we can perform an OPF from the simulation, this is the better profile of voltage at this substation.
So the red line is from simulation.
Yes.
Yang the blue line is from actual. Okay.
So therefore,
Therefore,
the voltage recorded
the voltage recorded is
lower than.
it's lower and it's not optimal and it's not flat as the red one.
Ah, okay.
Okay. Any question?
Why do you call it
What has
violation?
been violated actually?
Violated. Okay.
Violated.
Okay. Because I don't have any picture on the violated because I just take from the previous slides. So just pick one figure and put it aside. So just to show you.
Did you violate the maximum range that it can fluctuate
Yeah.
or what?
Not the fluctuate. Okay. Some violation in power system in the voltage violation is that you have the operating limits. Means that, for example, operating limits is in per unit value 1 to 1.05, and the emergency limits is like 0.9 to 1.1 per unit. Okay.
So this violates the range.
Yeah.
Is it the grid code?
Yes, that's it.
Should put the limit of the code lah.
Because it violated maybe.
Yeah. I know.
See, not only am I confused with the word violation, even technical people in this room also
I'm mechanical.
quite in disagreement. Okay, never mind. But you need to explain, yeah?
I'm pretty sure that these guys understand.
Yeah lah, you need to explain lah. You need to explain, okay? You need to explain.
But they are not going to be in the boardroom to help you.
It may be a long time since Datuk heard someone use the word violation.
Yeah.
Okay. Hopefully.
This is the second where you can observe massive megawatt flow, which is a reactive power flow. Okay. This is power generation. Okay. And this is a substation that we have the reactor. Okay.
Siapa yang
Okay. Okay. What is how the megawatt flow? Okay. It will flow. Okay. First, I want to explain the device. So generator is a kind of equipment that can supply or absorb electric power. Okay. And then secondly, here is the reactor, the substation. Okay, at substation normally they have capacitor, cap bank. Cap bank can supply electric power.
kuat lagi so?
Capacitor bank can supply electric power.
Yeah, okay.
Reactor can absorb reactive power.
Okay.
Okay. So in this example, we have two equipment here, generator and reactor.
Alright.
Okay. What is the problem?
What is the problem? Yeah.
The problem is that generator supplying electric power and this equipment absorbing electric power. Wow, you generate and you absorb.
Mana aku tahu kenapa?
This is the problem.
Then why did you design it like that?
It's not design. It's not uncoordinated and.
Uncoordinated.
That's the problem. Okay.
So generation dia bagi too much tapi substation habis sikit.
Yeah,
So,
yeah.
gila.
So you generate and you absorb.
Loss of power.
Loss of power. Correct.
Loss of power. Okay.
Okay. So we don't want.
But what about the ones that you circle tu? Tak nampak nombor tu.
Yeah. You said only 2 pages. I just I have only limited 2 pages. So
Oh, tak adalah. Maksudnya kalau nak you want to put on separate pages, you can.
Okay.
So that we can read the number.
Okay.
Otherwise, you circle also, we cannot read the number.
And
So read for us. What is the number?
okay, the number is that this is the flow, up and down. This is going right hand side.
Okay.
Okay. See here, the reactive power flow to this reactor about 162
Okay.
megawatt. Supply from to the reactor 5.049459.
1 megawatt.
This is megawatt and this is megawatt. The bottom one 116,103. Okay, generator generating reactive power and flow here and absorbed by the reactor here. This is massive megawatt flow.
Absorb by
Reactor.
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 Reactor? Reactor?
Yeah.
Reactor. Okay, yeah, sure, it's okay, no problem. But there must be a reason why you circle those numbers. So
Yeah.
what is it that you want to bring to our attention?
Okay. Just this is generator at where they can supply and absorb reactive power, and in this example they are supplying reactive power, and this is reactor where the character is absorbing reactive power. Okay. If the equipment supply and this one absorb, it shouldn't be this way. It should be this generator supplying reactive power to the load, not to this equipment, because the reactive power, the reactor should be used as a to reduce the voltage when the voltage is too high. It's not at the normal operation.
Okay.
Okay.
So it's always operating over.
Yeah.
Okay.
And uncoordinated because at power plant they have their own control engineer. Okay, they are controlling their own generator, controlling their own voltage, increase power. Okay. Somehow at substation, the control devices probably controlled by the operator at control center. And maybe they are located at Bangsa and LDC. Okay, somehow they are not coordinated.
Okay, next slide.
Only maybe sir.
Tak apa lah. It's okay. Continue.
So what is the implication? What is the implication? So as I mentioned, there are a massive of reactive power flow and voltage violation or voltage not as high as possible. So this will cause the high transmission system losses because you generate and you absorb somehow. You don't need to absorb, but you have to absorb. But so it makes the system losses increases. Okay, and then the most effect is that it will lead to depress the level of security of the transmission grid and economy. Economy is the losses. So you have more losses means that you are not economic in operation.
Okay. So,
So,
how severe is that?
I from somebody that he is a fellow in IEEE. So what he say, the most economical and operation of the high voltage transmission circuit is obtained when the voltage level throughout the circuit is essentially flat, and when that level is high as the insulation will permit. Flat and high. Okay. Position. So today I'm proposing a new method to coordinate these devices. I mean the reactive power devices.
Have you investigated this?
Yeah, as I said, we have done a preliminary study. So we already did some investigation, and we are proposing developing a new coordinated voltage control system, which has commercial grade and commercial grade.
Okay.